बर्तमान देखा केतोटी MCQ क्वेश्चन फर्स्ट a wire of resistance 4 ohm is bent in the form of a circle. What is the effective resistance between the ends of the diameter? So, here this is a circle and the resistance of this it will be 4 ohm. Then, so this is the two ends of a diameter. So, this is a diameter. So, this is the two ends of the diameter A and B. Now, आमे calculate करिबा what is the effective resistance between A and B. That means ए केस रे कोन हला ना diameter आमे जानिछु सर्कल को तार इक्वल पार्ट रे डिवाइड करे तने ए साइड रो वायर लेंथ जा ए साइड रो वायर लेंथ से तने टोटल resistance is 4 ohm. So, means that this side it will be 2 ohm and it will be 2 ohm. Now, this 2 ohm resistance and 2 ohm resistance they are connected across the same terminals A and B. That means, if a current I pass here, it is divided into I1 into I2. The means these two resistances are connected in parallel. So, when parallel it is connected, so if we take R1 is equal to this much and R2 is equal to this much, so now we know 1 by Rp is equal to 1 by R1 plus R1. As we know R1 is equal to R2, so Rp will be is equal to R by N. For equal resistance R by N, where N is equal to 2. So, therefore, R is equal to 2 by 2 is equal to 1 ohm. So, the equivalent resistance is equal to R by 4R means it is 2R, it will be 2R. So, it will be 2R by 2, so it is equal to R. So, the result will be option C. So, equivalent resistance will be R. So, next question, the equivalent resistance of resistors in parallel is always greater than the greatest of component resistors, less than the least of component of resistors, in between the least and the greatest of component of resistors, equal to the sum and least. Sum the least and greatest resistors. So, आमे देखिदेलु पूर्वरु सीरीज रे कौन हुए ना सीरीज रे the equivalent resistance will be greatest than the greater resistance and parallel combination आमे जानिछु resistance will decrease equivalent resistance. सेतिपाई the equivalent resistance will be less than the least of a component of the resistor. So, option B is correct. बर्तमान आमे देखिबा what is specific resistance and temperature coefficient of a resistance. आमे देखिछु गोटे particular temperature रे the resistance of a conductor direct proportional to length and inversely proportional to its area of a cross section. So, depends upon the material of conductor. So, R is direct proportional to L by A. Resistance also different for, but resistivity also different for different materials of the conductor. Therefore, we can write R is direct proportional to L by A or R is equal to rho L by A, where rho is the specific resistance or resistivity of the conductor. Therefore, rho is equal to RA by L or is equal to ohm meter square by meter, means ohm into meter. So, SI unit is ohm into meter. So, when L is equal to 1 and A is equal to 1, then we can define R is equal to rho. So, when R is equal to so, then we can write the resistivity of a conductor is equal to the resistance of a conductor of a unit length having unit area of a cross section at a given temperature, or we can say the resistivity or specific resistance of a material is numerically equal to resistance of a cubic conductor of a unity length. Resistance of a cubic conductor of a unity length. Means cubic conductor means length, breadth and height all are equal. So, area will become unit and length will also come unit. Then some keynotes or knowledge plus. So, resistivity is the specific property of a material, but resistance is the bulk property of a material. Resistivity is independent of a dimension of the conductor like length, area of the cross section. Resistivity depends on the nature of the material of the conductor, temperature and impurities. Resistivity of metals increases by addition of impurities. Resistivity of metals increases with addition of impurities. Resistivity of any alloy is more than resistivity of its constituent elements. Example, amara constantan, manganese, nichrome, these are the alloys and have high resistances. Hence, these are used for standard resistance boxes. Standard resistance box means आमे laboratory रे जो resistance box use करू से गुडी को हमरो generally constantan रे तैयारी होता है, because these are high resistance and as a alloy they are not contaminated by moisture or any. Also they are used in meter bridge, potentiometer, wires. Kahin silver, copper and aluminum have very low values of resistivity. Hence, these are used in making electric cables and connecting wires. Fuse wire. Sabu instrument man kare ba ghare ghare amaro fuse lagi thai to protect our house appliances from over voltage or over current. Sethipai kona na fuse is made of a material like tin lead alloy having low melting point and low resistivity. The elements of heater coils are made up of nichrome wires which has the high resistivity and high melting point. तो घरे जो हमारे हीटर यूज करूँ बा वाटर हीटर हो किंबा रूम हीटर हो, they are made of generally nichrome wires because they have high melting point and high resistivity. Because the high melting point न होबो हमर जतले हीटिंग होबो टेम्परेचर बढ़ी गले से मेल्ट करी जीवो. The filament of electric ball is made up of tungsten. आगो जो filament ball सब आसुथला से भी तार filament tungsten wire तैयार होता है which is low resistivity and high melting point. Now आमे देखिबा conductivity. The reciprocal of resistivity is called conductivity. The reciprocal of resistivity is called conductivity. So conductivity sigma is equal to 1 by rho. And the SI unit is ohm inverse meter inverse. Ohm inverse को आमे मध्य आगुरु जानिचो कहिथिलो, that is called Siemens. So Siemens into meter inverse. So resistance is equal to rho L by A. A is the area of cross section of the conductor is equal to pi r square or pi d square by 4, and pi d square it will go to numerator 4. Therefore, we can write R is direct proportional to L, inversely proportional to square of the resistance, radius of the wire, and inversely proportional to square of the diameter of the wire. Now a question. If a conductor is stretched or elongated or drawn them, the volume of the conductor is always constant. If length increase n times, then area of a cross section will decrease n times, and accordingly the radius of the circle also decreased. So first R is equal to rho L by A. So L into L, because area into length volume V is constant, rho L square. So R is direct proportional to L square. and rho how area? Rho L by A into A by A multiply kariba ame. So rho length into area is volume by A square. So rho V by pi square R4 or 16 rho V by pi square D4. That means R is inversely proportional to 1 by A square, R is inversely proportional to R4 and R is inversely proportional to D4. If the conductor is stretched, if L increase 2 times, resistance increase 4 times. If L decrease half, then resistance will decrease 1 by 4 times. Similarly, if area increase twice, resistance will decrease 4 times. If radius of the wire increase twice, then resistance will decrease 16 times. So see, R is equal to rho L square by V or rho L square D by M. Volume is equal to, because we know mass is equal to volume into density. Here D is the density of the material of the wire. So we can write rho L square into D by M or rho V by A square or rho M by D A square. We replace, in place of volume, we replace it density and mass. Now again, for small changes in the length of radius during the stretching, we can write delta R by R is equal to 2 delta L by I, delta I by I, and delta R by R is equal to minus 2, this is delta L by L, and minus 2 delta A by A, or minus 4 delta R by R. How? Because I janichu R is equal to rho L by A. When A constant, area or resistivity constant, then R is equal to some constant into L. Taking logarithm, we get log R is equal to log K plus log L, log base E. Because I janichu log AB is equal to log A plus log B. Now differentiating, we get, so you know derivative for log x is equal to 1 by x, so we can write 1 by R dr or delta R is equal to, so derivative of this is a constant, it will be 0, again it will be 1 by L into delta L. So if delta L by L will increase 2 times, then delta R by R also increase by 2%, it will be delta R by R also increase 2%. So if we stretch we change the length by stretching 2%. So now for a cylindrical wire of internal and external edge is ready, R1 and R2, then its resistance R is equal to rho L by pi R2 square minus R1 square, where R1 is the internal radius and R2 is the external radius. For a cuboid of dimensions length into breadth into height is resistance across AB RAB. So this face and this face is equal to rho L by, because it will be length, it will be area is equal to breadth into height. Similarly, if we CD, we calculate CD, then it will be length and it will be area. So, it will be length will be, this will be B. So, rho B by L cross H. And in case of EF, so this is the EF. Then in case of EF, we have here this much height is the, it will be length, so rho H by L cross B. And R maximum is equal to rho L by B into H, and R minimum is rho H by L into B. If L greater than B greater than H, then R maximum by R minimum is equal to L square by H square.